busways. Okay, so like I said, guys, I do hope you enjoyed the field trip yesterday at Boston Scientific. When we were there, Derek, we saw 25,000 amp. Did you guys see that? 25,000 amp. I'm sorry, 2,500 amp busway, not 25,000, 2,500 amp busways. And I think there was 1,600 amp. And you see how these busways are big copper or aluminum bars sandwiched together. So today we're going to talk a little bit about the busway. I already gave you guys two calculations, how to calculate the size of busways. The sizes for the busway, the standard sizes are in DeWalt. We looked at these. So what I'm hoping that we can do a little bit is the benefits of busways. Why should I go for a busway versus a panel? So every time, Karen, you hear of a busway, think of a panel. A busway is actually an extension of a panel. That's what a busway is, right? Because it's like panels, Derek. You can plug things into it. So benefits of it, we'll talk about a little bit of benefits of it. Common applications for busways, and you guys have seen a great application yesterday for busways, industrial manufacturing floor. That's the most common application for busways. The other application, I don't know if you guys saw when we were in the hallway, Adam, and they have all these busway right down the hallway, and they're plugging all the rooftop units to it. Did you guys see that? That's another application where you can take a busway and you plug all your rooftop unit into it. So not just manufacturing machines, but rooftop units. Components of busways, we'll talk about that. What does a busway make of in terms of elbows and angles and plugins and what's not. And various support systems. And in order to, I don't know if you guys were paying attention how they supported these busways. Sometimes you mount them against the walls or the ceilings, or you just bend them. So there's a whole lot, Adam, electricians, there's a whole lot of hardware things that you have associated with mounting and supporting the busways. Busways are heavy, guys, very, very heavy per foot. There are a lot of weight on them. So when you put a busway system, you have to talk to your structural engineer. Can you mount this busway from a wall? If you mount the busway, Adam, from a sheetrock wall, it will take that sheetrock wall with it. It will go down. So you have to pay a lot of attention to the structural integrity of the walls and the ceilings before you start mounting busways to them. So big deal. Okay. So busways. So the most important source of it, guys, transport electrical energy from source to the panel switchgears within a plant. So like you saw, it's looking right here, guys. I'm taking a feeder busway here. I don't know if you guys can see that. A feeder busway going right through my plant, and then a plug-in busway that plug all machines into it. So instead of bringing every machine branch circuit into the panel, Adam, I bring the panel to the machine. Right at the top of the machines, I put my panels in a form of a busway, and with a fuse switch and an SO cord, I can plug all my machines. So what are the busways, guys? Bus bars that carry current in a ventilated enclosure. That's it. Bus bar in a ventilated enclosure. When you guys look at them, they have a nice picture of it here for you in your book. Where did we go, Chad? Here. Okay, so here you go. So this is how it looks like, guys. Your busway looks like. You can find all the buses that you have. They just say this is phase A, phase B, phase C, all sandwiched together, insulated with a supporting insulating wrappings. We have the bus bars themselves. That's where the current goes right through them. We have enclosure, which is ventilated, if you can see, Adam. So there's a lot of heat inside these busways. The one that we were looking at yesterday, guys, was a 2,500 amp, right? This can go as high as 4,000 amp and even higher than that. A lot of heat generated out of these. So they have them ventilated, so that heat that generates out of the current going through the bus bars is ventilated. Yes, sir.
The bars on top of each other, to stagger them?
Yes, they sandwich them together. They literally put, depending how you can put them very, very close to each other, very, very close with insulation. That's how they get them to be so small. You know, they're carrying 4,000 amp, man. It's just looking. So they sandwich them and put special insulation on them. They get them.
They just fold them together, or?
Well, they don't. There's a bolt that actually goes right through here, but inside the bolt there is insulation here. That's where they put the three phase together, and there's a hole designed with an insulation. They put a bolt right through them and they torque them to make sure they stay within a limit, within certain distances. So it's there's a whole lot of techniques of adding them together, and you're going to see it. But the most important thing is you can see that you're looking at here's the bus bar that I carry exactly like in a panel gun. Say this is 4 inches, and let's just say a depth of 0.25 of an inch, a depth and length, typically 10-foot sections. That's what you're looking at. You're looking at a 10-foot section for this bus bar. Any comments, guys? Any questions about what they are? They are buses sandwiched together in an enclosure that allow them to be ventilated. That's your busways. Here's another look at it. Another look at the busway. And I don't know. I hope you guys had the chance to look at a lot of it. Here's the way they're doing it. Here's my phase A. They can sometimes they have multiple flinches. They have multiple bars for the same phase. I don't know if you guys can see it. They transpose them. They put them from the top. I don't know if you guys can see how A and B went to this area is B, A, and C. The A's, how they change them, and then the C's. To maintain the integrity of the impedance of the busway, every certain distance they transpose them. They put the buses, the one that was at the bottom, they put it at the top, and the one at the top, they put it at the bottom, and what's not. Any comments, any questions about the structure of busway? You guys have seen it yesterday, and you looked at it. Cable lugs and tab box straps. You can have cable lugs, and this is where you bring your cable lugs into this busway to feed into it, and we're going to talk about this one. Here's how your busway is going to look like, guys. You have seen this before. You take a big chunk of current out of the system. I think this was 2000 amp. You take a 2000 amp out of a unit substation, and you distribute all these power across your manufacturing floor. This is called the feeder busway, feeder number two, and then from the feeder busway you tab and you put a disconnect, fuse disconnects, and you feed your machine. Can you guys see that? Here's my fuse disconnect, and here's my machine. So we have a feeder busway that take the power to that location, and then a plug-in busway, which is their look-alike, except the plug-in has holes into it where you can plug in the loads. Any comments, guys? Any questions about feeder busway and plug-in busways? Adam, any comments? Any questions? Feeder busways, plug-in busways. So we have the disconnects. You can see all these are disconnects have to be sized. So if this is 2000, this is typically 225 amp. So these are 225 amp, all of these. All the reds are 225 amp. The blues are a 4000 amp coming in here. Can you guys see that? As a feeder, you have a circuit breaker. Typically, you'll have a circuit breaker right here, 225 amp. This is exactly what you guys are going to be laying out in our project. You have a big feeder coming with big amps like 2000 amp. Then you tap that feeder with a smaller amp like 225, and where you put your plugs, where all your plugs will be tapped with machine 1, machine 2. Here's here machine 3, and this one here is machine 4, and so forth. You're looking at it right here. Derek, you can see the blue here. My blue here. There are two busways, feeder busways. A feeder busway, guys, is not meant to be plugged into it. It's meant to take a big chunk of current from first floor to the third floor. When it reaches there, it transforms into plug-in busways where you have other. They look alike, except you can the plug-in busways you can plug things into them. So you can see all these oranges here. These oranges are actually the plug-in busways inside my plants here. The pink ones are trolley busways. We're going to be talking about trolley busways. You can move things while connected. So the blue ones right here inside our plant, you can see these are my two feeder busways. The orange ones right here is my plug-in busways. What's the difference? A feeder busway brings huge amount of power from point A to point B. When you reach point P, you need to distribute this power into all the machines. you use a plug-in busway. They look alike, except the plug-in busways has holes where you can plug in a fuse disconnect. Okay, so that's what I wanted to show you about the plug-in busways. Um, so here's my plug-in busways. Any comments, gentlemen? Any questions about busways? Plug-in? Any comments? Any questions? Take a huge amount of power. We looked at the busway. There are bus bars, phase A, phase B, phase C, and sometimes neutral. The ground, typically the frame is grounded. They're ventilated so heat goes out. Sections available, 10-foot sections. The width and the depth and the height, depending upon the amps, guys, you can go from 4-inch by 4-inch duct, guys, all the way into a foot by a foot, depending upon how is it 200 amp or 225 amp or is it 4,000 amp. And you can also have special orders for them, special orders. Then at the end, guys, you connect your busways. In our project, they're connecting the busway into the substation. There's a lot of hardware that you have to use, flange and end connectors. When you bring a busway into a panel, there's different hardware. You're going to be looking at them right in a second. There's something called transposing the position of the busway. Transposing the position of a busway, guys. So if this is phase A, this is phase B, this is phase C, what they do is they let them run, say, for 100 feet this way, and then they go back and they make them, let's say, C here, and C, A, and B. Can you guys see that? They transpose them. They put them in a different position by transposing them. By doing it this way, guys, putting the phases in different position, they are guaranteed that the impedance will be the same. So the impedance of each phase will be the same. So that's called transposing them. Why do we do transposing? That was on the test data. Transposing, putting them in different position inside the run for 100 feet, you put phase A, phase B, phase C. For another 100 feet, say, you put them C, A, B. By doing it this way, you reduce the overall impedance of the system. Reduce, why do we do that? Again, we talked about reducing the impedance of the system. Magnetic field effects, reduce the magnetic field. Opposition to the current flow is less, so you have less impedance, obviously, so you can pull more current into it. So can you guys remember the word transposing? Transposing is physically moving phase A from the top to the bottom. And then, of course, that would go with B and C. Okay, so we transpose them. In our project, gentlemen, we have two feeders. Feeder number one here is right here. I don't know if you guys can see it. You have the blueprint. If you have your blueprint, you should see that blue here. It's called feeder number one. The feeder number one in our project, believe it or not, it has this voltages, 600 volt max at 1,000 amp. We're pulling 480 from it, 480 volt. We have hand hole openings inside them. I don't know if you guys can see it right here, feeder number one. They have handhole opening into that feeder number one where they feed from it, located at every joint in the enclosure. Tap power. Why do we need it? We need to tap the power from the feeder busway. Feeder busways. Cable conduit takeoff, feed-ins also is there. So what they do, Adam, is they take right in here. I don't know if you guys can see right in here. They have a place where they tap power. This is not a plug-in. This is a box where you bring a conduit to it and you tap into that feeder. Any comments, guys? Any questions about feeder number one? Feeder number one is in our plant. It's going right along the perimeter of the manufacturing floor, and it feeds. That feeder number one is actually feeds multiple panels. Believe it or not, they're feeding panels out of that feeder number one. Feeder number two. Here is, here's the feeder number two. It's going right through the manufacturing floor. That's feeder number two. Large current values, minimum power losses. That's why we use them. Low operating temperature advantages. The amp wise for this baby is 600 volt at 1600 amps at 600 volt. The current density, I think you were working on this one there. The current density, which is basically the ampere square foot, is this amount 1311. So what that tells you guys, you can carry a lot of current in a square inches. Who cares? Smaller area, huge amount of power. That's a major advantage versus what? Wires, conduits and wires. And we did the math, I think, Karen, you did that math. Compared with the standard density of 1,000 amp of transposing the buses to reduce the impedance is evident. So that's what I want. The most important thing for using busways is a huge amount of current can be carried in a small amount of copper and a small amount of area, concentrated in one particular manufacturing floor. Okay, so, and that's why they again, I can't emphasize that when you take on the test and see the word transposing, what's the effect of transposing? Reducing the impedance of the system, the busway system, because of that huge amount of current. We looked at this one, guys, and I told you I have a feeder busway coming in here. That was feeder busway. We have feeder busway 2, which is 1600, not 2000, 1600. And then you have a plug-in busway. A plug-in busway, I believe they are 225 amp. And this is where your machines will be located. And here's my machine number 1. Any comments, guys? Any questions about feeder number 1? This is feeder number 2, feeding all these plug-in bus. So we have a feeder busway feeding a plug-in busway, right? Feeder busway feeding multiple plug-in busways, and in turn, the plug-in busways are feeding multiple machines. Can you guys see that? Right in here. Right in here. What's important for you, Karen, your project, not next week, the week after, when we start laying out power, this is going to be exactly around this way. Exactly this way. You're going to bring a feeder busway from the switchgear into the manufacturing floor, cap that feeder busway with 225 amp plug-in busways, and then from these plug-in busways, you're going to put a few switches that with an SO cord, and you tap into all these machines that we have in the manufacturing floor.
Was it the cable tray then that will run with the low voltage?
That's low voltage, yeah. Yep. Yeah, it will look in Revit, it will look like the low voltage cable tray when you guys lay them out. It look exactly the same, but it's actually a different family in Revit. We have a family, so Karen, we have family that's plug-in families and feeder families in Revit when we lay out our feeders. Okay, this is a couple of you were just asking me, Derek, about how the accessories and busways and what's not. It talks about the dimension, the slot holes that they have into them. I don't know if you guys can see it. They torque these straight end with so different type of hardware. I'm not going to go into them. How they put the system together. And I don't know if you guys remember. I think his name is Kent. Yesterday was he Kent? Kent. He was talking about how every year. Every 3 years they shut down and they go torque all these. They go all these bolts over here every 3 years. They go torque them and make sure that they're tight enough. Otherwise, they will arc. So busways, guys, like panels, need a lot of maintenance. Every year you have to do thermal imaging for them yearly. So you do thermal imaging like you do with all the other equipment. And on intervals of 3 to 4 years, you go and literally torque all these, tighten them, so they don't arc. A lot of hardwares. Feeder, so connect the number 2 feeder busways to a 225. Now feeder busway number 2, guys, have a 225 amp plug-in busways. These are very important. And they're right here, these yellow ones, they are fit from the blue one right here, and each one of them you see they have a fuse disconnect. Feeder busway bring the power into the plug-in busways. That's the job of the feeder busway. That's it. You got it. And tied in with a cord into it.
Yeah.
But look how the plug-in busway is tied to the feeder busway through a circuit breaker. Because it took you can see right here, a minute ago, right in here. Can you guys see that? This guy right here is my circuit breaker that's rated for 225 amp that will be protecting this section of the plug-in busway. Now here's going to be my SO cord, and this is going to be my fuse disconnect right in this area. Any comments, any questions, gentlemen? Comments, questions about plug-in busways? So, and feeder busways, very, very important. We have, like I said, also with it, we have two 225 amp circuit breakers. You guys have looked at them right here. They're back to back. Oops, right here. Can you guys see that? There's one in this side. Here's one here and one here. One feed this section and one feed the other section. Feed these two sections. These are your two 25 amp circuit breaker to protect the plug-in busways. Why do we have to have a circuit breaker, Karen? Because every time you change the size of the busway, you have to put the circuit breaker. For example, can I tie directly a 1,000 amp busway into a 2,000 amp busway direct connection? No, they have to be the same amps to be tied together. If you are to reduce the amps, what do you need to do? Circuit breaker or fuse disconnect. That's why we have the circuit breakers here. So for example, back to this, you can see that I'm bringing 600 amp. Can I tie the 225 amp directly to the 1600 amp? No. Why? Because this will be you can't protect this from overload. Right? So what do? The smarter than you and I always put the circuit breaker. It's like, guys, if you want to tab a conductor, number 14 conductor, tie it to a 4-aught. Can you tie number 14 to a 4-aught? Yes, you have to put the circuit breaker, tie it to the 4-aught, then from there you can go with number 14. That's a panel. You're creating a panel, basically. There's a couple of rules for tabbing, but for the most part, you can't do that. Okay, plug-in busways. Sub-feed take from feeder number 2, like you see, we're taking these ventilated feeder. From the ventilated feeder, we're taking all these power. We have 1, 2, 3, 4, 5. 5 times 2, we have, guys, 10 plug-in busways fed from feeder number 2. The power that's made out of this, the power system is 3-phase, 480. What do they do for living? Provide flexible takeoff. Flexible takeoff means for motor branch circuit. So as you do your plug-in, you have your fuse disconnect, and you take your cord and you tie it to your machine number 1. That's what the takeoff plug-ins will get you. How do they look like? They look like exactly a panel extending through the complete load area. What's the alternative of have a plug-in and SO cords, Karen? Get a panel like this and feed each one of these loads directly from this panel. Gentlemen, ladies and gentlemen, any comments, any questions? I can't emphasize the busway enough, guys. Why? Because the week after, you guys will be laying out that system for your friend Chad. So almost the same system. You guys not electricians, but if you are to carry the tools, Karen, and I know you went to a program, here's all the hardware that comes with it. When you're dealing with busway, guys, there's a lot of fittings, right? You have to have fittings that take you from up right angle. So they have different type of fittings to get you in different directions, flat and what's not. These have to be ordered so you can move in 3 dimensions inside this plant. So we have a right hand, we have edgewise elbows, we have elbows, we have left hand elbow, right hand elbow, flatwise elbows, right and left. We have T's, edge T's, and right hand flatwise T's. Can you guys see that? We have left hand edgewise T's, and we have left hand flatwise T's, and we have cross. The crosses, the flatwise, as well as the edgewise. Can you guys see the difference between the edgewise, how it looks like? They're coming, and the flatwise. So what's in it for you, Derek, when you start working for all these electrical contractors and you have a busway system and you're doing estimating, guess what? Every time you're going to cross like this, you have to go, okay, am I doing edgewise or flat? You know, I know you guys are not going to be torquing these, you're not an electrician, but if you are working for electrical contractors, especially, you're going to be taking off the system. You have to know a few things about the hardware. These are the most important fittings that they use to walk you. Remember, you're moving through this plant in 3 dimensions. So you're walking people 3 dimensions. These are not cables where you can, let's go there. It's like conduits. When you bend the conduit, you have to be able to bend the conduit. You can't bend these in the field. These are non-bendable. You have to move with fittings with them. So a big deal. Okay, Karen, my friend, your feeder, your plug-in busway, what did we say feeder number 2 size? Can't remember. Was it 1600? I keep forgetting that 1600. It's Friday. 1600. So the 1600 amp, guys. Here's my 1600 amp. 1600 amp, 480, three phase coming in, and I have 200. Can you guys see the circuit breakers here? Here's my 225 amp circuit breaker, and this is my 225 amp plug in busway. And this is another 225 back to back coming here to my plug-in busway. And this here is my feeder busway. Any comments, guys? Any questions about how this is kind of, they zoomed into that intersection here, Adam, and they showed you how they put the two circuit breakers in this cubicle. Any comments, guys? Any questions? My expectation, gentlemen, from you when you lay out your busway, not next week, the week after, is to do the same thing. You have to show circuit breakers for these busways. You have to do exactly the same. You bring, in ours, guys, you're going to see it's 1,000 amp. Most likely it's going to be your size, 1,000 amp, and we're tapping it with 225 amps. You know what a 225 amp busway, guys? It's exactly like a 225 amp panel. That's how much energy you can have. Okay, look at this. You guys were touring yesterday, Boston Scientific. You saw how their busway is laid out through their system. This is a view of how the busway can go through your system. It can feed machines, it can feed panels, it can feed anything you want it to. So you can it can feed a lot of equipment, guys, plugins and what's not. I'll zoom into that one later on. Method of suspension. There's a lot of ways of suspending it. We have another picture, guys. Now remember, we're going to look at all this, Adam. You're going to suspend all these systems somehow or supporting them, right, in the plant. So, which we're looking at them. So we have prefabricated clamp hangers you can use. Eliminate drilling, cutting, or bending associated with hanging construction on jobs. So there's a lot of prefabricated clamps that you can use. You can support them by rods or messenger cables. You're going to see a picture of these. You typically support it from the overall structure, so which this means you have to talk to your structural engineers, make sure you have, typically these are steel buildings, guys, with trusses, and they have enough juice on them to hold all these weight. Remember, there's a physical mechanical weight of these buses. And did you guys see how they were all mounted through the structure? So you have to have integrity in your structure. They support them at typically intervals of what, Adam? 5 feet. Every 5 feet, they support them. You're going to look at the picture in a second. Here's how it looks like, guys. You can support the busway through a messenger. I don't know if you guys can see that. And then you support my busway from here. That's what they call messenger. Bracket support. Here's my bracket support. You can also support it this way with bracket support. You can strap hangers. Look at that one, strap hangers. Bracket support that looks like this. What else? Rod hangers. You have your rod hangers hanging them. Can I just get you to give me a thumbs up, Chad? There are a lot of hardware that can go into supporting this system. Cool. That's all what I need. When it becomes a big deal if you work for Michelle Cool, Erickson, Adam, you probably would never get into that detail. Now you go for Hunter Egan and you start being an estimator, project manager. That's your baby. You have to be ordering all these support every 5 feet or so. You need to support your equipment. Any comments, guys? Any questions? Do you understand why supporting these busways become a big deal if you're a project manager? That's your baby. Expensive, expensive material, and it takes time to do it. Takes time to do it. Okay. Then what they have is something called a plug for every machine, guys. Every machine will have in the manufacturing floor have a plug. Derek, my friend, you're looking at it right here. It says ML here. Plug. A plug is basically a fuse disconnect, and you plug it in and you tighten it, and you take an SO cord from it and you feed your machine. So that you guys have seen all these cords coming down yesterday, hanging from the ceiling or from the busway. What do they do for a living? You have to have a so-called branch circuit protection for the machine. That's where the fuse become a big deal. Sizing the fuse, guys, will protect the machine, that particular machine, from short circuit and ground fault. Advantage of fusible plug-in units. Minimum number of sizes required, protective devices, rating, easily changed. So protected devices. So if I want to change the machine now, I have a 30 amp plug-in fuse, guys. I want to make it 15 amp. You change the fuse to 15, you have 15. 20, 25, 30, up to 30. You need to go higher than 30. Give you another standard 60. 60 can get you 60, 50, 45, 40, 35. You know what I mean? Give you a whole lot of ranges, the plug-in fuses that you can do. If the machine moves from this location into this location, like we were talking yesterday, disconnect the machine, unplug from this, and go right here, and plug it right here, and you're in there.
I thought they said that it was easy with the feeder too to do that.
Yeah, there's a lot of feeders. Feeders will take longer because there's a lot of termination. But the plug-in, you don't even touch a wire. You go untorque them, it's tightened. You know, you take that plug, couple of screws, take that plug, and you have to disconnect, of course, and go plug it there. If you're to touch with the feeder, though, you know, you have to take, you know, you have to shut the system down. This is, you don't shut the system down even. The busway stays hot. All what you shut down is the machine, so it's not running. So it's a great advantage. I'm so glad that we guys went to the field trip before we did the design. Okay, the project that we have, Adam, which is, we're looking at it right here, our project has, look how many plug-ins, protected devices rating. We have 47, 15 amp fuse, 30 amp disconnect. So we have, here's my disconnect, here's my fuse, and here's my machine, guys. Here's my machine. And this is also coming to a plug-in through the busway. Can you guys see that? There are 47 15 amp machines. And look at that. 26, 33, and 5 of 20, 30, 60, and 90 amp machines. And look at the disconnect that goes with it, guys. The disconnect size goes from 30 to 60 to 100. And Derek, my friend, you do have the sizes for the disconnect right here in the wall. You can see, so my fuse right here, gentlemen, my fuse is 15 amp and my disconnect is 30 amp. So I have a fuse disconnect. Typically, the disconnects come in a bigger sizes than the fuses. Fuses come in a more sizes than the disconnects. That's what I'm trying to say. Now in our project, guys, I think we have something like 20, 25 machines that we need to feed at different voltages. Okay, any comments, guys, any questions? That's basically it. Summary, bus bars, ventilated. You put a bus bar sandwiched together, enclosed in a ventilated enclosure to carry energy. They can supply cubic circuit breakers. There's a lot of methods of suspension. There's a lot of plug-ins. There's fittings that you have to pay attention to in order to move the system through the three dimensions inside that building. Okay, so that's I'm going to see if I have if I missed on some of the pictures that we can go. Okay, so here's what we talked about. This one, guys. We said how it relates to. Okay, there you go. All right, so here's my busway. We looked at busways, different way of connection. Karen, you can see where you bring the cables here through a tab box, they call it. That's if you want to tie to equipment. You tab with cables. Here's how you lay out your feeder. When we looked at this one, guys, you lay out your feeder busway, that dark stuff, and then this hidden lines. These are your plug-in, and the plug-in busways are tied to the feeder busways through a circuit breaker, 225 amp. We talked about this. A lot of hardware, a lot of torque that you have to do. If you're an electrician, Adam, you can see all the tools that you have to go torque all these connections. There are bolts that you have to tighten. Typically, they are thermal imaged every year, and every 3 years, like they were talking yesterday, they go there and torque certain areas. All the hardware that you need, I want to focus on this one. If you're going edge, they call it edgewise elbow, you can go left and right. If it's flat wise elbow, you can see how it looks like, guys, the flat versus the edgewise. You can go left or right, and all the way into flat cross. We looked at these as well as edgewise. We looked at the circuit breaker, Karen. We said you bring 1600 amp through circuit breaker 225, feed the 225 amp plug-in busways. This is why I want to focus a little bit, guys. Look at the busway here coming from the substation, going through the wall. Can the busway go through the wall? Yep, can go through the wall. And feeding right here. This is my transformer tab here. We have another one that's coming, taking power to different areas. Look at the plug-in. This feeder, guys, coming, and there's a lot of bus plug-in here. Plug-in branch run adapters and what's not. End tab with a switch. So here's an SO cord, for example. Typical method of flexible cable suspension. Can you guys see? Suspend it all the way and go to the machine. You can feed panels at them. Panel adapters, you can adapt and you go feed panel. Capacitor plug-in, you can plug in a capacitor. Fusible plug-in branch circuit, here's how it looks like, and you're going to tap into your machines anyway. So you can build a whole system, guys. Can I guys get you to understand, not only machines that you can feed from a plug-in busway, they're meant for machines with SO cords, but you can also have a box and with a conduit and tab a panel like they're doing in our project. They're tabbing panels from a busway. Okay, we looked at method of suspension, guys, from messenger cable suspension into all these strap hangers and what's not on the rods. Couple of ventilation. This is how it looks like, the cubicles. This is how your plug-in cubicle look like, guys. Tie together, unscrew it, move it to a different area if you want to. So a couple of pictures. We looked at the plug-in of fuses, right? And we're back to how the busway looks like. Any comments, ladies and gentlemen? Any questions? Does that make sense? Make sense how you do it? Okay. I can't emphasize, guys, so important this one for two reasons. Number one, our project require you guys to lay out a feeder busway and a plug-in busway. Exactly the same. So what I want to do, guys, I need to give you maybe 10 minutes, and I want to do very short. Oh, I forgot to show you something about color hammer. I went to color hammer, guys. It's right here. Here's a Power R busway system that color hammer has. There are 84 sheets about this. So when I ask you guys about bus cut sheets about busways that you're going to be providing, you're going to go to the busway. You have the book, the consulting book that you have. I'm just going to show you the electrical data. Here's the electrical data coming from. It's called Power R Way 3 low voltage. Look at the feeders, Adam. We have the amps coming in here. Here's my amps, aluminum or copper. If you're using aluminum, let's go to the copper. You can get them from 225 amp all the way to 5,000 amp. Can you guys see that? With the short circuits right here, rating for each and every one of them. So that's information from Color Hammer about the busways. A lot of physical information, guys, and fittings and what's not that you can find. And I'm not going to make it a whole busway day here. But you can find tons and tons of information, Karen. Color Hammer or Square D or in physical dimension. It will give you the physical dimension, guys, for all these. So physical data for every one of these buses with a neutral, without neutral, and what's not. Can you guys give me a thumbs up that say, Chad, we know where Color Hammer has their busway and we know how to find a cut sheet about it. That's my intention. Okay. Let's take like 10 minutes, guys. I want to go over panels, which is very, very short, and then I'll let you work on your low voltage. I know you were eager, Adam, to work on your low voltage stuff. Shall we? Thank you.